Uh, Hi, Algebra 2. This is the homework for Radical 2, and then we'll lecture on Radical 3 after this. Simplify each expression, so you want to break this down to perfect square roots. So 100 is biggest perfect square root, so square root of 100 is 10, so 10 root 7. I got 108. Okay, so 108, biggest perfect square might be, let's see, let's see, 108 breaks down. Let's see, we could break it down to 4 and 27, but I'm going to go a little further, x to the fourth x. 27 breaks down to 3 times 9, x to the fourth x. So a perfect square. Square root of 4 is 2. Square root of 9 is 3. 3 times 2 is 6. X to the fourth is perfect square. Take half of that, so you get that for an answer. Third root of 32. So 32 is going to be 8 times 4. 8's the biggest perfect cube, so that's going to give you 2 third root of 4. Third root of 135. Let's see, 135 breaks down to 27 times 5. 27 is the biggest perfect cube. 8 of the ninth is a perfect cube. We're going to change b to the seventh to b to the sixth and b to the first, which is just b. So third root of 27 is 3. Third root of a to the ninth is a to the third because 3 goes into 9. Third root of b to the sixth is b to the second. And then I have third root of 5b, or b to the first. So there's your answer. Let's go ahead and multiply these. So I get square root 30, square root 30. Let's see if it does break down. Any perfect squares at work. 4 doesn't go in. 16 doesn't work. 25. Nope, that's your answer. On this particular problem, this is going to give me root 55 over 14. So let's see if we can reduce that first. We don't have any perfect squares. So let's see, 14. Let's see, what's a nice perfect square that would work? I need to get to a perfect square, 14. I'm going to multiply both top and bottom by root 14, and see if it breaks up a little bit more. So 55 times 14 gives me 770 on top. On bottom is root 14 times root 14, which is just 14. Let's see if we can break 770 into anything. 4 doesn't go into it. 16 doesn't go into it. 25 doesn't go into it. 36 doesn't go into it. 770 divided by 49. Nope, that doesn't work. I'm just dividing them all out on the calculator. 64 doesn't work. 770 divided by 81 doesn't work. 770 divided by 100 won't work. Divided by 121, that doesn't work. 770 divided by 144, that doesn't work. 770 divided by, let's see, 13 times 13 is 169. That doesn't work. 770 divided by 14 times 14 is 196. That doesn't work. 770 divided by 4, or let's see, 20. Yeah, I think that's as far as you can go. That's kind of goofy. Okay, this one's going to give me root 100. That square root of 100 is just 10. This one I'm going to multiply outside, outside, and then inside, inside. Now, a couple things you could do. Think about this. I could multiply 27 times 30, which is going to give me a large number. But is 3 times 9 27? The answer is yes. What about 30? Is 3 times 10 30? So this is a perfect square, and I'm also looking for pairs. So square root of 9 is 3. If I multiply 3 times 3, I get 9. So square root of that gives me another 3 times 10. So 6 times 3 is 18 times 3 is going to give me 18 times 3 is what, 54? So I get 54 root 10. So that might be a little simpler to work through those problems. These, again, we might get some really large numbers. So let's break it all down. So 6 is 2 times 3. 8 is 2 times 4. 4 is 2 times 2. Agree? 10 is 2 times 5. All right, so I'm going to look for pairs. So I have a pair here. I have a pair here. Those are all my pairs. So if I take this, that gives me 4. Square root of 4 is 2. Square root of 4 is 2. 2 times 2 outside is going to give me 4. And then inside, I'm going to multiply the 3 and the 2, which is 6. 6 times 5 is 30. Number 10, I'm going to do the same thing. I'm going to make a big root. Okay, so 18 is 9, or 2 times 9. 9 is 3 times 3. And then let's do the 27. That's 3 times 3 times 3, because 3 times 9 is 27. And then I have a to the 4th. I'm going to hold on to that. And b to the 6th. So remember, multiplying like bases, you add the exponents. All right, so I have a pair here, and I have a pair here. Square root of 9 is 3. Square root of 9 is 3, so I have a 9 outside. This is a perfect square. Half of that is a squared. Half of that is b to the 3rd. And then what I have left behind is that 2 and that 3, which is 6. So we're all done there. Okay, third root. So we're going to do this the same way. 9 is 3 times 3. 6 is 3 times 2. We're looking for 3 of a kinds. So third root of that is going to give me 3, and then I have third root of 2 left behind. This one, I'm going to do the same way. 9 is 3 times 3. 15 is 3 times 5. Looking for 3 of a kind. So third root of that is going to give me 3, so I have 3 third root of 5. Multiply outside, so I'm going to get negative 15. And then I have third root of 4, so that's 2 times 2 is 4 times the last 2. So I'm looking for 3 of a kind, so that's 2. So I'm just going to get an answer of negative 30. The radical goes away because I had a perfect cube. All right, now I'm going to do fourth root. And this is where this idea might get a little easier. I get 3 times 3. I have that outside too, so I'm going to bring that up front. 36 is 3 times 12. 12 is 3 times 4. This is my 4 of a kind. The fourth root of that is just 3 times this outside is going to give me 6, and then I have fourth root of 4. Number 15, I'm going to distribute over, so that's going to give me 4 root 14 minus 49. This is a perfect square, so 4 root 14 stays as is, minus 7, and we're all done. There's no longer a radical. Multiply here and here, so I'm going to get 150. I don't know why I made my radical so big. Plus 3 root 50. So I think 25 is going to work here. So that's what, 25 times 6. And then this is 25 times 2. Square root of 25 is just 5, so I get 5 root 6. Square root of 25 is 5. Multiplied by the outside 3 is going to give me 15 root 2. There's our answer. We're going to FOIL these, so I'm going to multiply here, here, so that's root 33. So here, root 22, root 6, root 4. 33 doesn't break down to perfect squares, no perfect squares. That's the only perfect square, so I'm going to get root 33 minus root 22 minus root 6 minus 2. All right, let's change colors. Go orange. Multiply here, that's going to give me 12 root 20. Multiply here, that's going to give me minus 21 root 14. Here, that's going to give me positive 4 root 50. And then multiply here, that's going to give me minus 7 root 35. So root 20 breaks down to 4 times 5. Square root of 4 is 2. So I'm going to get 24 root 5. Root 14 won't break down. That's just going to stay as is. This is going to break down to 25 times 2. Square root of 25 is 5. 5 times that outside is 20, so I get 20 root 2. 35 won't break down at all, so it's just going to be just like that. There's your answer. All right, let's take a look at the notes on this page. So we're looking for the 3 of a kinds like we've been talking about. So let's start breaking it down. 56 breaks down to what? 8 times 7, because 8's the perfect cube. I'm going to make the a to the fourth, a to the third times a. And then b to the eighth, I'm going to make b to the sixth, b to the second. So the third root of this is 2. Third root of this is a. Third root of this is b to the second. And then I have left behind 7ab squared. Number 2, outside, I'm going to get 10. And let's, I'm going to break this down. I get 2 times 3. 21 is 3 times 7. Here's my perfect square. That's 9. Square root of 9 is 3. Multiply to the outside 10 is 30. So I get 30 root 14. Go ahead and distribute here and here. That's going to give me, it's going to get big numbers. So I'm going to get 2 and 5. And 15 is 5 and 3. Plus 3, 10 is 2 and 5. And then the root 5 left behind. This is a perfect square. That's 25. Square root of 25 is 5. So I get 5 root 6 here. Plus square root of 25 is 5. Multiplied to the outside is 15 root 2. Okay, so that's some words. For any non-negative numbers a and b where b is not equal to 0, the natural index k, where the k root of a and k root of b are real numbers. As with multiplication, this property can be used forward and backwards. Okay, so let's take a look. Square root of 25 is 5. Square root of 36 is 6. This is the same thing as square root of 25 over square root of 36. I think that's what we're trying to do. This particular problem, again, this is square root of 25 over square root y squared. They're both perfect squares, so I get 5 over y. This one, same idea. I'm going to get 4a to the third, b to the second. Number 4, the third root of 27 is 3. The third root of 343 is 7, so I'm just going to get 3 over 7 there, okay, because 343 is 7 times 7 times 7. All right, the third root of 27 is 3. The third root of y to the third is just y. The third root of 125 is 5. The third root of z to the ninth, well, 3 goes into 9 3 times, so z to the third. Done. Let's see, for this one, so square root of 4 is 2. Square root of d to the 8th is d to the 4th, times square root of c squared is c. Square root of 25 is that. And then that's going to give me 2c, 5d to the 4th. Now we get into some things that don't have perfect roots. So divide before you simplify completely. Okay, so, take a look. Both under the radical. Does 5 go into 18? Yes, it goes 16 times. So I get square root of 16. Square root of 16 is just 4. Take a look at this one. If I divide 5 into 120, they're both under the radical. I just get root 24. Root 24 breaks down to 4 times 6, which is 2 root 6. All right, fourth root. Okay, they're both fourth root. So this is going to give me the fourth root of 81 because 2 goes into 162 81 times. Fourth root of 81 is just 3 because 3 times 3 times 3 times 3 is 81. This particular problem, the inside 2 goes in there, so I'm going to get 5. Third root, 2 goes into 32 16 times. All right, so then I can break 16 down to 8 times 2. Third root of 8 is 2, times the outside 5 is 10, so 10 third root of 2. Reduce where you can. 7 goes into 14 twice. 2 goes into 250 125 times, so third root of 125. What's the third root of 125? Yeah, it's just 5, and then 5 times the outside of 2 gives me 10. These are fifth roots, so it looks like this should start simplifying. 2 goes into 64 32 times. All right. I'm going to do something here. I'm going to still have a fifth root on bottom. Tug of war with the A's. Bottom wins by 5. Tug of war with the B's. Top wins by 10. Okay, so now this might work out. So fifth root of 32 is 2. Fifth root of b to the 10th is b to the second. Fifth root of a to the 5th is just a. So talk to your teacher about the tug of war thing. And then take a look at RAD 3 worksheet. Work on that, see how you do. Take your time on it. You might get stuck on some. That's okay. We're learning. We're learning. But let's take a look at this. Okay, do that whole worksheet. Have a great day. Great day.